So good morning, everyone. And for today, there will be, of course, the discussion on the new topic, continuing from the previous time that we discussed on, what is it? Distributed model, right? Now we will continue with the CAP theorem, which is still very much related to the distributed architecture of distributed data mechanism and so on. But before that, let me recap a few important things I think we need to know about that together. First, it's about next week. As I already mentioned that as part of this course, we need to have, not we need, but I like to have, that is invited speaker to give some lectures and case studies and so on related to data governance, data privacy, and certain sample cases from the industrial sector. So it's going to be next Wednesday. I'm trying to find a better room. So it may not be this room. We will change to another room, but I will confirm the room very soon through email. That tentatively, okay, I'm trying to check a few things, but tentatively, let me write some here. Okay, tentatively, the talk for the next week would be okay, the title, the topic is data privacy and data governance foundation case study.
Excuse me, I cannot hear you. Excuse me.
Is this one better? Now, do you hear me? Yes, okay. Perhaps the battery is gone, I believe, I would presume. All right, so anyway, you didn't miss anything so far. This is still what we mentioned, but this to be confirmed. Oops. Okay. Find out where is this Milton-Bender auditorium. Okay, but it will be confirmed first to make sure that we have the hybrid facility. Okay, so that is about next Wednesday. Okay, so be sure to be there, basically, to make sure that you can give warm welcome to the speakers because they are coming. I mean, 2 of them are coming and they will be here giving a talk and so on. So that's about the next week and nothing else. Okay, what else I should say? Okay, back to this. I still have to talk about the midterm exam, but I perhaps do it after we finish the lecture. Okay, that's still to be discussed. I already have my slides for discussing a few other things related to the exam, but keep you calm a little bit and then discuss it at the very end before we finish the class. Okay, now we go back to this CAP theorem that is the main focus of today. Okay. What does CAP theorem stand for or about? Okay. Okay, anyway, so CAP theorem is an acronym referring to 3 concepts. First is consistency. For the C, A, availability, and P for partition tolerance. Why are we talking about CAP theorem? Because within the concept of CAP theorem is very important because when we are talking about distributed database system, that means we are not storing data in just one centralized server, right? But you are, from the previous week, we discussed already that we may need to distribute our data into multiple nodes and so on and connecting them. And when we need to connect or store data into multiple places, either we partition them, either we store them through some kind of replication and copies. Still, there are very many complicated issues to discuss. That is, we need to be able to, I mean, from the very good property of storing data, we want to have data consistency. And remember last time we discussed also the issues of maintaining consistency among those many possible distribution models, right? So consistency for sure is one important issue. Second is the availability. And third is when there is the network partition, whether what to do in this case. So these are 3 important properties that we will consider in the CAP theorem. Consistency for C, partition tolerance, P, and availability, the A. And let's look at one by one in together in the big picture first, and then we go into some detail. When we have data distribution, so let's look at some thing like this. You have, okay, we use this symbol for a database, right? Data store. When we have some kind of distribution, oops, maybe this is not good. You distribute data into 3 nodes. Okay, consistency means that every of these nodes must see the same copy, because whether you use master slave model, remember from last time, right? Or whether you use peer-to-peer model and so on, user may access, some user access data from here, some user access data from here. We want to make sure that different users, even accessing data from different places, they see the same data, right? Otherwise, distribution doesn't make sense. Why we distributing and then we have a lot of conflicts in terms of data mismatch or inconsistency. So consistency is very important. We need to make sure this, okay. Second, in terms of availability. Why do we distribute the data? Because we want to increase availability of the data, right? Because if everyone accessing single server, single node at the same time, then there could be performance issue. Availability may be very low. It is very slow, or it may even go corrupting, crashing, so on. So availability means that even some of the node would fail. Okay, you cannot prevent that. There could be the case that some of the available nodes may fail. But availability means that even some of the nodes fail, others, suppose I say A, B, and C here. Even C fails. A and B is still working, right? Survive. So the failing of certain nodes do not prevent the other nodes to work and to return data and to give service. You cannot prevent this node to fail, but if it fails, user may connect to some other nodes and obtain the data that they want. Okay, so this is about availability. We still have multiple nodes to work when one node fails. The third one, partition tolerance. This is about network failure. Okay, that somehow we divide or partition network into multiple parts because of network failure. And again, network failure is something you cannot prevent, right? It's some unfortunate event that may happen. Okay, but we need to make sure that the system continues to operate despite network partitioning. Okay, so this is the same as I already explained in terms of consistency, but let's look into more detail together so we understand all of the 3 properties together, and we will discuss later on that which properties, I mean, you cannot have them all. You cannot optimize to have all properties. You may need to trade off or choose and balance that. You want to optimize the consistency, but maybe you reduce or you trade off from the availability or something. Okay, but we will look into the detail first. Is there any? Okay. Let's read this first. Okay, this is from kind of definition. When a database system is said to be consistent or it maintains consistency property very well, it means that all distributed nodes, user connecting to any node, should see the same data at the same time. So this is very ambitious definition, right? Anytime you connect from any node, you should see the same data. It should not be that, suppose I am here connecting and reading data from any of these nodes. You use any kind of query statement, select this and that from this and that, right? Finding out the value of the data. Suppose the data we want to find is we somehow, okay, this is for kind of input, so updating. If you update the data to store the value map at this particular time, 103, okay, you are updating, you make changes. The change supposed to propagate to all the nodes, right? Even you change in only one node, it must propagate to everywhere. So it must propagate to every of the nodes. If another user is reading the data from this node, after the time of update, the other user must see the change for the data map, right? It should be something else, but now we update or change it to be map. But again, this scenario says that another user at some time later change the data, update the data to another value, art, the same data, but change it to art, maybe the register cost, okay? You say here that you want to study math, maybe that is not usual case, right? Your mother say that you should register math, and she register math for you. You later on say, no, I want to register for art course, okay? And then at another node, someone else, when processing or querying the data, he should have seen the latest up-to-date data for sure, right? That means art. There should not be, if it is after this last update, nobody should see math anymore because the data value has been already replaced. But in real scenario, it really cannot be controlled that way. It really have to have certain good controlling mechanism, okay? Because now we are trying to recompete the update from two different nodes. But actually, this update should finish complete first. Then, of course, someone else do. So this is supposed to be number 1, number 2, and number 3. So consistency ensures that all data read everywhere in the distributed system should have seen the same data. And we already discussed from last time, right? Such as when you want to book a hotel, if it is the last room available, you see it available, it really means available, right? But it should not be that you see it available while someone else already booked it, because now you are fighting for the last available room of a hotel, something like that. Okay, so this is actually to explain what I just discussed. Okay, if we perform a read operation on a consistent database system, when your database system is consistent, your system should return the value of the most recent write because it's the most up-to-date data. Okay. And that actually means that all the nodes should store the same data value. Otherwise, different user reading data from different places would have seen different values. Okay, so that is for consistency. I think it's easy. Next is about availability. Availability means that user always get answer. When you connect to a system, you must have some answer. when you request for some data, you must have received an answer or an output. You submit something, then you get answer back. That is availability. Okay, so when your system is available, it means you connect and ask for a query, then you get the result returned. It's very important here. Availability does not mean that it must be consistent. I mean, it's two different things. Availability means the system is available to return you the answer, but it doesn't mean that the return answer should be correct. Okay, it's another story. If the answer is to be correct, it is guaranteed by the consistency property. But if your system is available, always 100% available, it means user can 24/7 connect and ask a query and get data back. That is availability. Okay. So it could be that when you query here, you must have something returned. It should not be like system not available, server error 404 or something. Okay. And then partition tolerance. This is what we already discussed. Whenever there are some node malfunctioning, or there are some of the network partitioning, such as these are all the nodes in the distributed database system. You have certain data center or data server, data node in Boston, Chicago, San Francisco, London. So this connects the North America, right, with Europe and Asia, and even Australia. Okay, this is Asia, this is Europe, this is somehow North America. Okay. You have all data, you have your nodes distributed across the world. And somehow connection, network partitioning happens, disconnecting the two, disconnecting networks. Okay, so back to the partition tolerance, it means that you cannot avoid network partition to happen. But whether you choose to continue to be available or you choose to continue to be consistent, this is what you have to choose. Suppose, okay, imagine this, network partition really happened. We break, this network break the entire distributed system into subsystems. What happened? If I want to make sure that all data is, if I want to impose strong consistency property of my data, what should I do? Okay, this partition already, right? First, I say that I want to ensure strong consistency property, meaning I am here connecting to Beijing node. I want to make some changes. I want to update the data. Can I update? If I update, will I still make my data consistent? At least it may be consistent only in this part, right? But not the other part, because I cannot replicate the change or synchronize the data, the change, right? So if you really want to ensure strong consistency, it means you are making your system not available because the system refused the request, right? My request is to change. How about if my request is to read? Maybe if we assume, right, that before the network partition happened, everything is in a very consistent state, then is reading okay? Right? Should not be there for strong consistency, right? Reading, maybe okay, right? Because we assume that reading doesn't make any change to the data, so we allow user to read. So let's think about e-commerce system. I can continue browsing the catalog, but I cannot make a purchase. I cannot add any item into the, maybe adding into shopping basket doesn't make any big loss anyway, but trying to check out the basket, right, may be a problem if we really don't know the status of the product. So reading may still be fine. So the question is, these two things must be traded off. You cannot have both at the same time. I mean, for the maximum, for the most extreme. If you want extremely consistent data, you cannot have extremely available system, because at some point you will say not available to the user. No, we cannot give you this service at this time. We are now synchronizing the data, or we get network disconnection, and then we cannot be sure that consistency can be maintained. Then writing the data must be suspended, right? Okay. But if you choose availability and you ignore the consistency, so you want to give service to your user as highest as possible. Whatever user wants, do it. I am available. My server is available for you. User here can do all the write. User here in this network can also do all the writing. Okay. Let's think about something like social media, Twitter, Facebook, Instagram, in which you are not committing to any much, I mean, in which network partition happened like this. Of course, data synchronization could not be fully possible, right, across two network partitions. But what's wrong? If it is social media, doesn't make any harm. Whoever wants to update your status, you want to update your status, your friend wants to update status, do it. But maybe you cannot read all the status of all the user in the other part of the network, right? You cannot read because the status of the updates are not synchronized yet. But you can update yours, post yours. You can see the updates from friends in the same network, fine. Okay. But if this user A and this user X, of course, they would not see each other updates, but the system remain available. right? Any read and write can still be done, but not fully consistent data that you would achieve. So you see these two different stories, right? Whether you choose when partition happens, you are the owner of your Mark Zuckerberg. You want Facebook to completely shut down, or you want Facebook to continue to serve to different parts of the world, but still data are not fully synchronized. But still user can do something. They can still see certain status, not all. They can still write their own status, but maybe not everyone see it. Okay, but sometimes you are happy, right? If at least you can post, but you might be a little bit annoyed if nobody see your post or you don't get any like, feedback or anything. Nobody click like, nobody reply, nobody follow or something. So that could be a little bit annoying, but at least it's better that you can still do something, okay, on those social media. So what is the thing is that in a system, this is the conclusion. In a system, distributed system, distributed database system that may suffer from network partition, you have to trade off between consistency and availability. You cannot have both extreme at the same time. You can optimize, but it is not a binary choice, meaning that not totally consistent and then unavailable, or totally available but then inconsistent. No, you can have like 50% consistency, 50% availability, or something like that. Okay, tune them, tune these two properties or parameters. Okay, these additional example would show you better as well. So these are the two distributed data store. One has mango, one has apple. Network partition occur at the time that the change has been made. So what do you want to choose? If you choose consistency, you need to wait until network is back. Then you synchronize the data, right? If you choose consistent data, your system will become unavailable. You wait until this is fixed. But if you choose available, then your user is living with inconsistent data for some period of time, okay? But until network is restored back to normal. So as I said, you need to choose according to the application, the need, the requirement, how serious when your system is unavailable, or how serious when your system is not consistent. Okay, so for sure, these two people, they can still making use of the data and system, but data are not fully consistent. That's it. Okay, as I said, there is no right or wrong answer. You choose what is best for your use case requirement. Okay. So you may need, as a developer or development team or database engineer, data engineer, you need to propose to the management, to the business management, business lead, to choose. But you need to be technical consultant, right? You should be able to understand the implication of both choices. So the criteria that you may need to consider would include what or how much the cost could mean, how much of investment you need to make in the technical investment to achieve consistency. Because if you want strong consistency and also very fast, right? You can say that you want consistency, but if you have distributed network, it means it would take time to synchronize all the copy of the data, right? So how fast? If you want super fast, of course, you invest a lot in terms of your physical resource, internet bandwidth, network bandwidth, and very many things. Okay. So how much does it cost to maintain consistency versus how much does it cost in case inconsistency happens? Do you really want a real time? Or some delay is acceptable? Of course, real-time consistency would be very expensive, but could be important in some critical system, right? Such as trading. If you trade cryptocurrency in Thailand, you don't really want to be slower than the other user or traders in the other part of the world, right? You really want to compete with the real time, something like that. Okay. Another question to ask is that how important it is to achieve high availability, or it is fine to throw errors and say, I'm not available. I cannot answer this question right now. I mean, query right now. Is it okay for user to wait for the availability of the system? And the third question you should ask is how much latency can be tolerated? Latency means it's very slow response, right? It has high latency, something like that. So keep in mind that high latency sometimes is the same as not available, right? When you wait, now I think people have become less patient. Everything must be super fast, right? You click something and you expect it to give you the result immediately. While sometimes it may take you a few seconds, but you don't have the patience to wait and even refresh, right? If you keep it a few more seconds, it may come, but no, you think that perhaps better refresh. So that means the latency is too high for you, right? If you can't wait. So what is the latency that is acceptable? Because latency could mean data are synchronizing. You cannot see the immediate result because data are synchronizing and it doesn't return to you the up-to-date data result yet, okay? But if you can't wait and the system must return you something, maybe the return result is not the most up-to-date. Is that okay? When it is not the most up-to-date, it means what? It means here. It means it's not the consistent. It's not the most recent, right? The most recent data that has been written. Okay. Okay. And Another last question you may need to ask, how complex a solution could get. You may want to say that, hey, I want to achieve high consistency and high availability. But again, your solution, technical solution should be very complicated to ensure this and that and so on, right? Also, in the case of network partitioning, how can we do all these types of synchronization and so on? Okay, so if you want simple solution, you want cheap solution, you don't want this and don't want that, then maybe you need to analyze this, and the answer based on how you answer all of these questions will tell you what possible solution, technical solution you should use. Okay, and so these are all things related to the CAP theorem. We talk about CAP theorem because we are focusing now not a centralized database system, but we are talking about distributed data system, in which it could be the case when you have high volume of data, when you want to increase availability and distribute your data across the network, considering what we discussed from last week, right? Okay, so these are the three properties in the CAP theorem. And there is another kind of related concept, which is called PACELC. I think it should not be read as the acronym, but it stands for this whole statement. So please have a read. It says that if there is a partition, mean network partition, okay, how does the system trade off between availability and consistency? For sure, as we already discussed in the CAP theorem, when there is network partition, the P happens, you must trade off. Either you choose one against the other, or you balance some ratio, right, of one for the other. So we trade off availability and consistency. Otherwise, actually, another aspect we could consider is we trade off latency against consistency. Remember, latency and availability is somehow related. Instead of not making your system unavailable, you make it a little bit with high latency so that you can still ensure consistency, but slower response. You need high consistency. That means you need data synchronization, right? And it will lead to higher latency for sure. Okay. So for sure, these are the two contradictions. Everyone would say, if you ask the business, the management, anyone, they would say, I want high availability of the system. Whenever the user make any data request, they should receive or get the answer, get the output. There should not be, people often say zero downtime, right? There should be zero downtime. User must be able to get the answer and must be served. System must be available 24/7. So business often want high availability and high consistency. When you ask that, can you tolerate 2 copies of the data and not the same value? Usually they will say, no, we want to make sure that data are consistent and correct, right? But actually, you can talk in the detail because we cannot have both, as I already said. And actually, another way to trade off or balance this for certain application is having high availability. Still, user don't like at all when system is not available. But still, if system is slow and not available, is not the same thing, right? But again, low latency we want, and consistency we want. What you can trade off is that we can consider, and we will talk about this in more detail, which is called eventually consistency. It's not consistent in real time. Like we change here, I change things in my laptop, and all the change happen to your laptop at the same time. This is very fast, right? And real-time consistency. But eventually consistent means it may take some time, but eventually we will all get the same data consistent in all the nodes. Okay. So there is another concept instead of very strong consistency model. It is called eventually consistent model. Okay, and this is what we will discuss in another set of another topic in the next topic as well. Okay, so I think this is more or less about the CAP theorem, in which we need to be able to understand the importance of consistency, availability, and network partition, and they all are somehow related, but they all cannot be satisfied at the same time. Okay, question? Yes? I could not hear properly. Sorry, can you make it a little bit louder? We can have two properties guarantee. Okay, actually the CAP theorem states that whenever there is network partition, only consistency or availability can be guaranteed, but not both. Why? As I already mentioned here, when we have network partition, if you choose consistency, it means you disallow people to make updates, right? And when you disallow certain services and access to the data, it means your system is not available. But if you choose that people should the system should be available, all users can do everything they want to the system. What does it mean? It means some user may change the data to Mango, some user may change the data to Apple, and they are never synchronized because of network partition, and this means not consistent. So when there is a partition, only C or P, or C or A, but not both, right? Is that the question you asked? Okay, is that clear to you? Okay. Okay, another question or not? from the online? Do you have questions? Okay. If not, then I stop sharing this slide.